In today's lesson, we're going to be looking at the carbon cycles in the Amazon rainforest. This is for the OCR A-Level Geography Spec 2.A, where we need to know how carbon interacts with the tropical rainforest. So the two areas we're going to look at today are the carbon cycle in the rainforest in general, but then also physical factors and how they affect stores and flows. So one of the most important things to know is that carbon is really rapidly taken from the atmosphere and moved into the rainforest. There's a couple of reasons why this is able to happen. Because the Amazon rainforest is above the equator, it gets really intense solar radiation and high temperatures all year long. This combined with the heavy rainfall, so high temperatures and heavy rainfall, we've got 2,000 millimeters a year on average, they allow really good conditions for photosynthesis to occur. And when we get photosynthesis occurring, we obviously get vegetation growing. So carbon is moving from that atmosphere into the biosphere at a very rapid rate in the tropical rainforest. I'm going to talk a little bit about what that looks like, and one of the kind of figures that we look at is something called net primary productivity. We say it's very high, and it means 2,500 grams per meter squared per year is the kind of figure that they use for the tropical rainforest. What that actually means is that's where I take how much CO2 is taken in by the vegetation and used for photosynthesis and for growing the tree, and I take away the carbon dioxide that's lost through respiration. So with a figure like 2,500, that tells me that more carbon is going into the tree and being captured and sequestered in the branches and stems and the rest of the tree than is actually going back through the cycling process into the atmosphere. So 2,500 grams is a lot. If I looked at temperate forests, so the kind of forest you find in the UK, that would be significantly lower, closer to somewhere between 600 grams to maybe 12,000 grams. What this looks like when I look at it from a satellite, I can see that if I look at the area of Brazil and South America where the Amazon rainforest is, it's green pretty much all year round, and this GIF is showing me through the years, so it stays green all year. And that word that we use is evergreen. That means even though the leaves are lost during the year, they are the tree cover as general is evergreen. That means it's not like a deciduous tree in the UK where it would lose half of its leaves in the winter period. I've talked about rapid cycling before in terms of water, and the similar process in terms of the carbon cycle. We have movement of carbon, flow of carbon between the atmosphere and biosphere, and that's because we've got such high temperatures. It allows that the process of fixing the CO2 through the process of photosynthesis to happen at a really fast rate. We need high temperatures for photosynthesis to happen quickly. But also, because I've got those high temperatures, that means decomposition, bacteria and fungi are going to be very active, which means they're going to release lots of CO2 to the atmosphere. So we're seeing rapid inflows and rapid outflows happening between the atmosphere and the biosphere. What's interesting about the tropical rainforest in terms of the soil is it's actually very infertile. There's a limited amount of nutrients in most of it, and you can see this guy who stood next to this huge bit of soil, and that kind of washed out color shows that there's not a lot of nutrients in it, apart from the very, very thin layer at the top, which is a layer we call the humus layer, and this is where all of the biomass above on the ground is actually supported, and I'm going to talk a little bit how that works in a second. So how this works is the trees, these evergreen trees, they are losing their leaves all year round. They don't lose it at one part of the year like deciduous trees, and because they're losing it all year round, that can then be attacked by those high temperatures. The bacteria can decompose it really quickly. It means that the carbon created in those organic compounds in the tree leaves, they actually break down and they go into that thin layer of soil, but they don't stay there that long because the trees are trying to grow because of the high temperatures and lots of sunlight and lots of rainfall, and so those roots in the tree actually take that carbon up really quickly, and that means the trees grow rapidly. We see that this is that idea that there's rapid cycling of the nutrients and the carbon between the soil and the tree. So again, it's a process that's happening really quickly. It's not taking ages and ages to happen. And the reason why the rest of the soil has so little nutrients is because the rainfall is so heavy all year that any kind of nutrients that's in that layer below would be washed out. I'm going to talk a little bit about stores now. So we know that the Amazon rainforest is a really important store. 100 billion tons locked up. 2.4 billion tons of CO2 get taken in each year, and 1.7 get released back into the air every year through respiration and decomposition. And therefore, because it's taking in more than it's releasing, we call it a carbon sink. The most important thing in terms of carbon storage in this carbon sink is these evergreen trees. They store 60% of the carbon above the ground in branches, stems and leaves, so really, really significant. That means 40% of the carbon will be stored in the kind of roots below the ground. In terms of how much they can store, 180 tons of carbon per hectare above the ground is what one tree can actually store. And like I said, still carbon is stored below, so 40 tons per hectare in the roots, but very, very significant difference in terms of above ground and below ground. Physical factors, as in the water cycle, obviously have effects on the carbon cycle. So if I have those high temperature and rainfall, I'm going to get lots of photosynthesis, which means carbon's being rapidly extracted from the atmosphere. Again, we've already kind of discussed this already, but we're going to get those high decomposition rates if we've got high rainfall and temperature, because the temperature will make sure that bacteria and the reactions happen very quickly, and the rainfall will make it nice and moist, which is what fungi and bacteria like to have to be able to exist. And therefore, even though carbon's being absorbed from the atmosphere rapidly, we're getting it released rapidly back into the atmosphere as well. The last thing to really consider in this kind of part of the carbon cycle in terms of physical factors is geology. We discussed in terms of water that there is large sections of the Amazon rainforest which is made of these shields. They are igneous or metamorphic rock that make up a large amount of the Amazon basin. Because they're igneous rock, they don't really have many carbonates in them, so and they're also very difficult to weather, so any carbon that would be trapped in it would be hard to get out. But the most significant thing is they don't have a lot of carbonates in them, unlike something like chalk, which is a calcium carbonate and therefore has got carbonate in it, and so if anything reacts with chalk, then the carbon will be released. So these igneous rocks don't have a lot of carbonates in them, and they're hard to weather, and therefore geology, because so much of it is igneous rock, these crystalline shields, that it's not so significant a store in terms of carbon compared to the atmosphere. The only kind of area in which there is a significant carbon store is these limestone outcrops, and limestone has got carbonates in it, and that's in that kind of west near the Andes. So close to the Andes you get these limestone outcrops, and they have carbonates, and so in that area they are significant in terms of the amount of carbon that they can store in the geology.